Hi students, let's see about the derivation part. Magnetic field on the axis of the circular current loop. Here we are taking the circular loop of radius r and we are taking a part of the circular loop and considering that length as dl. In the diagram we can see the dl is considered as the top as well as in the bottom. And this circular loop, it is placed in the three coordinate system, one is x, y and z. And we are taking a point P which makes the angle theta with the dl. With the length dl, the point P should make an angle theta according to Biot-Savart law also. The same thing. Always we take the test point P which is away from the point, that is it makes the angle theta. Now let's take the triangle AOP or OAP if we are considering. Then the radius of the circle is r, the distance where the point P is taken is x. So the hypotenuse is taking r is equivalent to root of r square plus x square. Now what is cos theta? R divided by small r. Substituting the r value will get r divided by root of x square plus r square. And r value also we know, root of x square plus r square, that is r square is equivalent to x square plus r square. Now all these things from the diagram part. We have taken a loop and the consideration related to the theta value and distance. Now let's go to the derivation part. According to Biot-Savart law, we can say dB vector is equivalent to mu o divided by 4 pi ideal into r cap divided by r square, where r cap is the unit vector. And if you want to find out the b vector, means we need to take the integral of dB vector. But here we are taking only the cos theta component as it lies along the same parallel to the x coordinate, and the bx sin theta is perpendicular to the b vector, perpendicular to the x coordinate. From the point P, if you are looking, dB sin theta is a perpendicular component. So everywhere if you go for the circular loops dl, then the dB sin theta will get cancelled. So we'll take only the dB cos theta parameter, which is dB parallel. We cannot take the dB perpendicular parameter. We can take only the dB parallel, which is dB cos theta. So by taking the dB cos theta value, substitute in the dB vector value. So b vector is equivalent to integral of dB vector is equivalent to integral of dBx cos theta into I cap. Now substitute the value of the dBx from Biot-Savart law and cos theta value from the triangle. Will get, then r cap is the unit vector. So r cap into I vector will give you the same thing, that is I cap. So substitute all the values, you will get mu o divided by 4 pi ideal vector into r divided by r square into x square plus r square to the power 1 by 2. Square root we can take in terms of 1 by 2. So r square into x square plus r square to the power 1 by 2 into I cap. Now we will substitute the value of r square, that is equivalent to x square plus r square, and the limit, as it is a circular loop, its circumference varies from 0 to 2 pi r. So take the dl with respect to the limit 0 to 2 pi r into I cap. Meanwhile, x square plus r square into x square plus r square to the power 1 by 2. So power, if we add the power value, we'll get x square plus r square to the power 3 by 2, and mu o I divided by 4 pi remains as a constant one. Substitute the limit as it varies from 0 to 2 pi r. Apply the integral limits 0 to 2 pi r and consider x is very less than r. That is the point where the P is located is very small comparing to the radius of the circle. Then b vector is equivalent to mu o I divided by 2r into I cap. We need to cancel all the values, we'll get the same.